Hello, welcome to Memphis Communiversity. My name is Quads. Oh no, you can't see me writing my name. I'll move my face. Okay. My name's Quads. I just finished freshman year of college. I'm doing the absolute minimum maximum worksheet. So if you're wondering, what is that? When you're looking for an absolute minimum or maximum versus like a local minimum or maximum, also known as a relative minimum or maximum, you're basically looking for the tallest mountain or lowest valley in a curve, in a graph. The local ones are just any mountain, any valley. Doesn't matter how big. So you can have like a bunch of little ones and then a big one. This tallest one here, that's your absolute maximum. And so we're going to try to find those in this worksheet. And remember, you can get the PDF of this worksheet and the answers in the description. So we're going to do a three-step process here. Also formally called a closed interval method, but we're just going to call it the three-step process. And our first step is to locate the function that you're taking the absolute minimum or maximum of. And this is a super important step for two reasons. First of all, it's really helpful to write out the function because eventually you're going to plug numbers back into it. And even if it's the same function given in the problem and you're like, why am I rewriting this? This is dumb. It's the same thing. It's helpful, at least for me. I find it's easier to process the numbers and just like plug it in and do the mental math if I've written it out. And then also it's really important to write it because sometimes the function given is not the function that you're looking for the absolute minimum or maximum of. And if you're wondering, how could this be? I need an example. We're going to get there. Hold your horses, but a lot of the times, like, it is the same. And so you're going to be like, why am I just writing this down again? Because it's the same. Just do it, rewrite it, like locate the function even when it is the same, because you don't want to get to one where it's different and get the function wrong because you're going to miss the problem. So yeah, go ahead and locate the function every time. It's just the easiest thing to do. And next you're going to find the critical points. So if you don't remember, a critical point is when you take a derivative of the function and then you set the derivative equal to 0. So you're going to find the x values where the derivative equals 0 or where it doesn't exist. Also, I forgot to note up here, I meant to write down that you're locating the function of which you're looking for the absolute maximum or minimum. So if that was unclear or you just like having things written, forgive me for missing out the first time, but I went ahead and added it back. But yes, now we're on to step 3, which is the table. So you're going to make a table with these critical points and your endpoints, and then you're going to plug in those x values, those critical points and endpoints, into this function that you've located. And then you're going to get the y values, and those y values are going to be your maximums and minimums. And so you're going to, from those y values, figure out what's the absolute maximum, what's the absolute minimum. Okay, I'm going to move my face up so you can see everything clearly. So we're going to start with number 2, which is pretty simple. By locating the function, this time, yeah, we're just rewriting it. But just go ahead and do it. So y equals x to the third plus 3x squared minus 9x minus 2. And then for critical points, first step of that, so step number 2, find critical points. And then within that, first thing you're going to do is take the derivative. So we're going to get y prime equals 3x squared plus 6x minus 9. And a lot of times I'll write 0 equals in front of the y prime because you are setting this equal to 0. This time I forgot to write it, but it's helpful if you just go ahead and write that 0 equals y prime and then write the derivative. But yeah, I mean, you can format it how you want. If you prefer to write the equals 0 at the end, you can do that too. Sometimes I'll like write a new line and like write 0 equals, and like after I've gotten it in factor position, then I'll like set that equal. just to get all the middle steps out of the way. It's easier for me to see. But yeah, so we're gonna factor this, simplify it, and then factor as much as possible. Because we want critical points, we want those x values that we can then plug in to find the minimum and maximum. So for this one, our x values are -3 and 1. I want to underline this because, yeah, I just set this equal to 0 here at the end. You can do it at the beginning. You can do both if you want, however you want to do it. So now we're going to make a table with our x values and our f of x. So the first value we're going to put in this table is 0. And you might be asking yourself, what about -3? So the first value is always going to be this left point in the interval. And your last value is always going to be the right point. If you have critical points that don't fit within that interval, we're going to completely ignore them because we are finding the absolute min and max of a function in the given interval. So it doesn't really matter if there's a bigger maximum outside. Like, let's say -3 happens to have a bigger maximum. That's irrelevant because the question isn't asking for that. It's asking for only between 0 and 2. So we're just going to ignore -3. So we'll have 0, and then 1, and then 2. So make sure you include both critical points and endpoints. And so then we're going to plug in 0, which is -2. Plug in 1, you get 1 plus 3 minus 9 minus 2, -7. And plug in 2, and you're going to get 2 to the third plus 3 times 2 squared minus 9 times 2 minus 2, and that's going to equal 0. So our absolute maximum here is 0. That's the biggest y value. And that occurs at x equals 2. So you're going to write both of those pieces of information. And then we're also going to write the absolute minimum, which is -7. It's the smallest y value. And that occurs at x equals 1. So just to clarify, the absolute maximum value is the y value. So the absolute maximum value is 0. Some questions might ask, where does the absolute maximum occur? If it asks where, it's asking for the x value. So the absolute maximum value is 0. And where does that occur? It occurs at x equals 2. And you can think about that, like if you just picture a function on a graph, you're looking for like the tallest mountain. So we're going to say like it goes all the way up to 10. It's like not a very big graph maybe, but okay, it goes all the way up to 10. That's your biggest value is 10, your y value. But you want to know where that happens. Let's say it happens at like, okay, we'll just say x equals 2. You want to know that it happens like, oh, I can't do like a little thing, right after the origin instead of like before it or something. Like you want to know what the value is, the y value, and then where it occurs along the x-axis. So that's it for number 2. Number 3 is also pretty straightforward. The locate the function, it's again the same thing. So I'm going to go ahead and write y equals 2x squared plus 4x plus 5. And then we're going to find those critical points. So this time, yeah, I wrote 0 equals y prime. I just stuck it in the front. So yeah, 0 equals the derivative of this function we've located. So to locate the function, 0 equals the derivative. And then we're going to get those x values for our critical points. Do our simplification magic. We love that. And our critical point is x equals -1. So this time, yeah, like I said, I'm talking about 0 placement a lot. It's important to me, apparently. I just rewrote it again. X equals -1. This critical point is not in our interval. So we're not even going to have any critical points this time. Your table should always have at least 2 points. It should have the interval, start point, end point. But this one doesn't have a critical point, so it's only the 2. So yeah, we plug 0 in there, 0 plus 0 plus 5, and we're going to plug 2 in there, so that's 2 times 4 plus 4 times 2 plus 5, we're going to get 21. So our absolute maximum, biggest y value, 21, and that occurs at x equals 2. Our absolute minimum value, smallest y value, 5, and that occurs at x equals 0. Number 4, we're going to get some fun factoring here. Once again, locate the function. It's just y equals x to the 5th minus 80x. And for critical points, set the derivative equal to 0. So that's going to be 0 equals y prime equals 5x to the 4th minus 80. And we're going to factor that into 5x squared plus 4, 5x squared minus 4. Because if you take, I think I excluded the step, if you factor out the 5, you get x to the 4th minus 16. So that's the difference of squares. I know it's sometimes confusing in factoring when we skip steps because you're like, wait a minute. Or at least for me, I'm a really visual person. So sorry I missed that one. And then we can break this one down even more. So that's going to be x minus 2, x plus 2. And this x squared plus 4, so remember we set this equal to 0, so we're trying to find, just like rehashing of like basic factoring, we're trying to find what values of x could we plug in to make this whole thing 0, and since they're all multiplied, we just need any one of these to equal 0, right? X squared plus 4 is never going to equal 0. We know that because x squared would have to be negative 4, and you can't plug in a number, square it, and expect it to end up negative. So x squared plus 4 is not going to equal 0, which means it's not going to give us a critical point. So we can basically ignore it because we need one of these two factors to give us 0 to make the whole thing 0. So we got x equals plus or minus 2. And I'm just going to like cross that out just for like visuals. And then we're going to go ahead and make our table. And this time, once again, only one of our critical points fits in the table. And 2 is actually the endpoint. Obviously, you're only going to write it in the table once. It wouldn't do much to write it twice. You would just have the value down twice, which would probably just confuse you. So this one's only 2 points again. Abs max is 79, and that absolute maximum value 79 occurs at x equals negative 1. Absolute minimum value is negative 128, and that occurs at x equals 2. And also, I didn't go through plugging those in, but remember, we are plugging these two into this, so negative 1 to the 5th minus 80 times negative 1, and then 2 to the 5th minus 80 times 2. And then we got our biggest y value, smallest y value, and where do they occur. All right, number 5. Ooh, we got a quotient rule this time. I don't like the quotient rule personally. I don't know how you guys feel about it. Our function, once again, we're just gonna go ahead and write that as it is, x squared minus 15 over x minus 4. And we're gonna take those critical points. So derivative, do that quotient rule, and you're going to get x minus 4 times 2x minus quantity x squared minus 15. And then all of that is over x minus 4 squared. That's a beautiful, beautiful derivative. Not. So let's simplify that. So first distribute this 2x. And I wrote, you can't see it right now because my hand's in the way. I wrote minus 15. That is a plus 15 because this minus, I just was not paying attention. And then we're going to keep simplifying that. I noticed it here. And we're going to keep simplifying it until we get it as factor as possible. What's interesting about this one is when it's a fraction, remember that for critical points, we are looking for where the derivative equals 0, but also where the derivative doesn't exist. And so that means we're going to set both the numerator and the denominator equal to 0, because if either of these equals 0, whole thing equals 0. If x minus 4 equals 0, whole thing doesn't exist. That's still a critical point. So don't exclude those denominators. And so we actually get 3 critical points this time, 3, 4, and 5, which is really satisfying. I love that. And we'll plug those into our table. Oh, but dang it, only one of them occurs. And here's this little side note about 0 or do not exist. I don't know about you guys, but I get kind of invested. Like, I did all that work to find the critical point, and then, like, they're not even on the interval. I think it's a little frustrating, personally, when 2 of them aren't on the interval and the other one is, like, literally the interval. But that's just me. And so when we plug in 1 squared minus 15 over 1 minus 4, we get 14 thirds. And when we plug in 3 squared minus 15 over 3 minus 4, we get 6. So remember, I should arrow it to this function, not the one in the problem, because we've located it. Always refer back to the one you wrote, not the one in the problem, because they might be different. So here I am breaking my own rules, but yeah, this is what we're plugging into. All right. So our absolute maximum is, highest value here is 6. Absolute maximum value is 6, and that occurs at x equals 3. Value 6 occurs at 3. Absolute minimum value is 14 thirds, and that occurs at x equals 1. Okay, now we get to go to the other side. I always think it's kind of exciting when I get to the other side of the worksheet, like we're making progress. This one is another fun factoring one. Once again, the function is just y equals e to the x times x minus 5. And then we're going to take those critical points. So 0 equals y prime, so derivative set equal to 0. And that is e to the x plus e to the x times x minus 5. But I definitely wrote it as multiplied here because I was having a brain fart, so forgive me. I will eventually realize it's plus and fix it. Yeah. And that's e to the x times x minus 5. And then we want to go ahead and simplify that. And that. You know, I did it again. I wrote multiply. That is a plus. Because we distributed this e to the x times x minus 5. So this is definitely a plus. And I did it again. Just, I'm off my game today. But there we go. The 5 e to the x, negative 5 e to the x plus e to the x, you get negative 4 e to the x. I don't think I ever corrected it on this one in pen. This is plus. Oh no, this one's not. Man, I can't even correct myself. This one, I'm so sorry. This one is this. This is e to the x times x. This is from distributing. I think I need to just write them closer together, otherwise I'll confuse myself again. It's also partially because I made the exact mistake above. So this is e to the x plus e to the x times x minus 5 e to the x. And then once we get rid of this guy, then it's just e to the x times x minus 4 e to the x. Forgive me. Factor out that e to the x, you get x minus 4. So this is all correct. If you didn't follow all my mistakes right there, this, as it's written, is right. Our x equals 4, so now we got our table. Oh, it fits, yay. So we got 0, 4, and 5, 3 values. You know, I realize that I complain when there's only 2 values in the table because I'm like, I did all the work to get the critical points. But having 3 values means you actually have to like plug in 3 values. So we plug in 0 here, get -5, plug in 4, we get negative e to the 4th, and plug in 5, you just get 0. E to the 4th, e is about 2.7, so we know that e to the 4th is way bigger than 5. Which means negative e to the 4th is way smaller than -5. And that means it would be the absolute minimum. We'll get there though. Absolute maximum value is 0. That occurs at x equals 5. Absolute minimum value, negative e to the 4th, that occurs at x equals 4. Alrighty. We get some trig here. I don't like trig. You might notice me saying that in like every single Memphis Communiversity video I make. Sorry. Y equals x plus sine x. Critical points, take that derivative. So 0 equals y prime equals 1 plus cosine x. So we've got our derivative, set it equal to 0. We know x needs to be pi. And so we got our endpoints 0 and 2 pi, and we've added in pi. And what's kind of crazy here with trig is that sine of 0 is pi. Sine of 0 is 0. Sine of pi is 0, and sine of 2 pi is 0. So basically these are all 0, and it's just what it went in as. Sorry, these are not all 0. I'm up here. This is why we locate the function. Here I am plugging it into the derivative. That's not even the common problem. The common problem is to like switch if like you're given a different one. I can't even do it when you're given the same one. You plug it in here. Sine of 0, pi, and 2 pi is all 0. So basically, we're just looking at like 0 plus 0, pi plus 0, 2 pi plus 0. So we just get those. That's all up here. So yes, here's our little fun fact. All these equal 0. We love trig. Absolute maximum value of the function is 2 pi, occurs at x equals 2 pi, not 2. And absolute minimum value is 0, occurs at x equals 0. Okay, number 8. This is the one where locate the function is super important for normal people and not for me who confuses it even when it's like just given. This one, you see we have f of x, and we also have g of x. So which one to do? Okay, so this is the function that we're like looking for the minimum and absolute minimum maximum of. But we need g of x to locate what f of x is. But once we do that, once we plug g of x into f of x, we don't need it anymore. Throw it away. No, don't touch it again. When you plug it in, you're plugging it back into f of x. So it's super, super important to locate the function every time, but so that in moments like this, you don't accidentally look back and you get down to the bottom and you're like, table, x squared minus 2. No, it's f of x. So locate the function. And I'm just going to go ahead and write it first with the g of x, the way it's written. F of x equals g of x times x squared, and then I'm going to write it again now with the g of x in there. So that's x squared minus 2 times x squared. And then I'm just going to write the whole thing again, just without the middleman, so it's like visually more clear. F of x equals x squared minus 2 times x squared. And then I'll just go ahead and distribute it so it's easier for critical points. That's x to the 4th minus 2x squared. That's just this. So this is our function. We're going to revert back to this. Ignore that now. This is our go-to. And this is also why in the earlier problems when I went back up here to plug in, it's just like the point of writing it is like to get in the habit of looking here, because if we did that in this case and I went back up here to plug in, it wouldn't even matter that I wrote it. So just like in all of them, practice writing it down and plugging it into the one you've written for step 1, locate the function. Okay, critical points. 0 equals derivative 4x to the third minus 4x. We're going to take out a 4x. We got x squared minus 1. And that's a beautiful difference of squares. I've always liked those. X minus 1, x plus 1. So now we have all 3 of these give us critical points. X equals 0, 1, and negative 1. And my negative 1 you can't really see, and I'm really sorry. Sometimes I just write it over the top just like for mental, like this is where I got the 0, this is where I got the 1, negative 1. Not really relevant. Also, I just X that out because like it doesn't fit in the interval. But then I realized you can't tell it's a negative 1. I'm sorry, that just looks like a mess. But if you're now confused, zoom back a couple seconds, it's a negative 1. Okay. Negative 1 doesn't fit in the interval, like I said. So we got 0, which is a critical point and an endpoint, 3, 0, 1, and 3. So 3 is our last one because it's the second endpoint. And when you plug those in, down here, look what I just did. I literally went straight up to the g of x. This is why. Okay, plug it in here, 0 to the 4th minus 2 times 0. Okay, that one's 0. And then 1 times negative 1, or not 1 times, what am I saying? I'm so sorry, guys. I'm obviously just not on it right now. We're plugging in 1 to 1 to the 4th minus 2 times 1 squared, and we get negative 1. Plug in 3 to the 4th minus 2 times 3 squared, and we get 63. So our absolute maximum value here is 63, and that occurs at x equals 3. And our absolute minimum value is negative 1, and that occurs, negative 1 occurs at x equals 1. Also, I haven't said this before, but the reason like I write out this whole thing at the end every time is because like here's your justification, like this whole process, but you want to like actually clarify, like pinpoint like what is the minimum and maximum and where do they occur. Okay, number 9. This is another one where the function given isn't necessarily what you're taking maximum minimum of. So it wants you to take the maximum or minimum of the velocity function. But it gives you the position function. So the function we're locating, the function that we're going to take the absolute maximum minimum of, that's v of t. But we can't just look at the problem to have v of t. Like even in the one above, it still gave us f of x. We just had to plug in g of x. This one, we actually have to take the derivative of the position function, because if you remember, the derivative of position is the velocity function. So we're taking a derivative just in the locate step. And then we're going to have to take it again in the critical points. But we're locating the velocity function, which is s prime of t. And that is negative 3t squared plus 6t plus 9. Okay, so also our interval is 0 to 2 because it says this is the first 2 seconds. So yeah, you kind of have to interpret those a little bit. So now that we've located our velocity function, that's the function we're looking for the min and max of, we now find critical points of the velocity function, which means we take now the derivative of the velocity function and set it equal to 0, just like we've been doing. So really the only difference between this one and the other ones we've been doing is that you have to take the derivative to locate, and then you do the same thing from there. So we got negative 6t plus 6, t equals 1. And we can go ahead and make our table 0, 1, and 2. And make sure you're plugging your table into the function we located, which is the velocity function, which is s prime of t, not the function given in the problem. This is why we do this locate step. So now we plug 0 in, you just get 9. 1, negative 3 times 1 plus 6 times 1 plus 9 is 12. And 2, negative 3 times 2 squared plus 6 times 2 plus 9 is not also 12, it's 9. I don't know what I'm saying. It's 9. So our absolute maximum here, our absolute maximum value, well, since this is a velocity question, we can say our absolute maximum velocity, that is like the y value here, is 12, and it occurs at t equals 1. And our absolute minimum velocity, since these two are the same, they are both the absolute minimum velocity. Well, both times. So you just write 9 once, because it would be kind of weird to write 9 and 9. So you're only going to have the one minimum. The minimum is 9, but it occurs at both t equals 0 and t equals 2. But I guess if you're just thinking about, like, what's the slowest velocity, like, the car ever has, the slowest it ever has is just 9, will be one number, and it just has that slowest velocity at two spots. All right, we're on the last one. Yay. This one is kind of like the one we just did, except for now the function we're locating is acceleration, but we're still starting from position. So that means we actually have to take 2 derivatives just to locate the function, because we're locating a of t. And I'm going to be silly here, and I think I just wrote s of prime of t as this one because my brain, once again, was not functioning properly. So forgive me, I'll realize it and correct that and realize, this is another problem. It has a different function. Yeah, here we go. So the velocity first thing you have to do is s prime of t, first derivative, 4t to the third minus 6t squared plus 18t plus 5. So that's our v of t. That's one derivative. And now we take the second derivative. So we get 12t squared minus 12t plus 18. And so this is the function we've located. I realize that this is all very messy, but this is the acceleration function. And so this is the function we've located. And our interval is first 3 seconds, so it's 0 to 3. So now we do our critical points of this function, this acceleration function, which means now we're going to do a prime of t. So this is now the third derivative you will have taken for this problem. So we're taking the derivative of acceleration, which is what we just located. It's easy sometimes. This one you kind of have to, because like acceleration is just a prime of t. But for the one we just did, for the velocity one, it can be easy to get like tripped up, at least for me. I write v prime of t and then I want to write, well, that's acceleration, but like in problem number 9, there's no reason to write acceleration because that would just, at least for me, just confuse me. If I leave it as like v prime of t, then I know I'm taking the derivative of the function I just located. So like I don't really want to call this one s prime of t, that'll confuse me. I want to like locate v of t, no derivative, even though we've already taken one to get there, and then take the derivative of v of t. So this one we're locating a of t and then taking the derivative of a of t. But it's kind of inherently like that for acceleration because there's not like a next one. Like there's velocity, position, velocity, acceleration, and then next would just be a prime of t. Anyways, that's my rant for organization wise. But yeah, we got 24t minus 12, t equals 1/2. And now we can do our table. And we got 0, 1/2, and 3. And remember, when you plug things in, you're plugging it into the function we located, which is a of t, because we're looking, it tells us to find the maximum of acceleration. So we plug in here. Let me pause this and go through these. 0 minus 0 plus 18, got 18. 12 times 0.5 squared minus 12 times 0.5 plus 18 is 15. And then 12 times 3 squared minus 12 times 3 plus 18 is 90. So our absolute maximum acceleration, you can like stick the word acceleration in there, I didn't write it, is 90, and that occurs at t equals 3. And absolute minimum acceleration is 15, and that occurs at t equals 1/2. So that's the video. This is our last shapes of curves review. So you can find videos for all shapes of curves topics, from like increasing and decreasing, concavity, local minimum maximum, and this one, absolute minimum maximum. You can watch all those videos to get the whole topic. I hope this one was helpful. If you're finding these videos helpful, go ahead, like and subscribe. You can find more on the channel done by other girls doing calculus. And if you have any questions, you can comment them. And there's also a link to the Discord server in the description, which you can put in your own calculus questions or like ACT questions that you come across outside of the questions on these worksheets. So remember, the PDF for the worksheet and the answers is in the description as well. I hope this was helpful, and have an awesome day.